This example is going to automate faults systematically at the point of connection to a strong grid. So it's a 230 kV source, and the initial, for strong source impedance, it's 10 ohms. So the short circuit MVA is there 5290, so short circuit ratio of almost 53, very strong grid. When we do these faults systematically, we don't have to open a line or transformer to clear the fault. The initial conditions don't change, and also the fault duration is 0.3 seconds. So some of the ride-through requirements are 0.16 seconds. So these faults last longer than the ride-through requirement in IEEE 2800, and so for some of them, the IBR may trip, and that's allowed. So the source impedance is 10 ohms, or it's 26.4 millihenries. And if we apply that same inductance to the fault, so if we want to retain a 50% voltage, if we put a fault inductance of 0.0264 henries here in each of the phases, A, B, and C, if you look at it as a voltage divider with L grid and LF, then we're going to get a 50% voltage division of the 230 kV right here. So that's going to give us a 50% retained voltage for as long as that fault is on. We can also have different types of faults. The first 4 rows here are A, B, and C to ground, which means that all 3 of these switches are going to close when the fault is applied, and this ground switch here is actually going to stay closed. So 3 phases to ground with different inductance values here. So of course real faults are not inductive for the most part, but what we're trying to do is set up retained voltage or voltage sag scenarios with the fault inductance. We can leave phases B and C open and just close A with G already closed, and that's going to give us the phase A to ground faults. 4 different levels of inductance, so we're expecting 4 different values of retained voltage there. And finally, we can simulate phase-to-phase faults, say, for example, between B and C by closing those 2 switches. We don't close the one on phase A, and in this case, we leave the ground switch open, so we're getting phase B to C faults. Using the same inductance values as before, so we may not get the same retained voltage to ground, but it's the same fault inductance. We could, and in some cases we'll need to later on, we'll need to simulate B and C to ground faults. I didn't do it here, because we already have 12 different fault scenarios, and with the legend on the plot, you'll see later, 12 is plenty. I didn't want to do 16, but that's the only reason for that. And again, the faults, I believe, are applied after the plant reaches an initial condition, and we close, let's say, 1 second into the simulation, or 5 seconds into the simulation, and then 0.3 seconds later, these switches are going to open to clear the fault. So no physical power system breaker had to open to clear those faults.